Good morning. Speaker's on, I'm on, and let's get going. Good morning, everybody. Hopefully you enjoyed waking up to see a nice sunny morning, at least where I'm living in the Hoffman Estate, Schaumburg area, and it should be sunny by you too. All right, first of all, about half hour or less ago, I sent out an email with the test number 1 password. You have until tomorrow, 9 a.m. to take the test, take and make a PDF file of all the pages of the test and upload it to the assignment area. If you have some sort of problem, let me know, we'll work it out, but you should all be able to get it to me by tomorrow morning. Let's see, take all the time you need. Normally, if I were in a classroom, I'd give the students 55 minutes. For this test, most of them are done in 40 minutes. Remember, you should not look at your notes. You should not go online. You should not talk to other students. That's called cheating. And I put secret stuff in there that I can know if you're cheating. I developed it last semester when we went online. And that's one of the few things that gets me upset. Students are cheating because that's just wrong. It's a form of lying, and lying gets me upset. Other than that, I'm pretty laid back. Now that I had my first sip of tea, let's get going. All right, today's lab on Zoom, which you'll do all, that's the only part you'll do is on Zoom, deals with the elements. And essentially what they're going to ask you to do is which is an alkali metal, or which is an alkaline earth metal, which is a halogen, which is a noble gas. And I'll ask you some other questions. What's a metal? Remember, something that has luster, thermal conductivity, electrical conductivity, and malleable, means you can spread it out. How do you like that? Anyways, it doesn't work that well. I tried it and I got stuck in a part and couldn't get forward. Just go online, try it out, answer a few questions, and when you get frustrated, bail out. That's good for me. And I can check if somebody went in and at least tried it, and you'll get full credit. Shh, don't tell anybody. Remember, don't tell anybody. And that's today's lab. Again, on the bright spot, by being able to use Labster and you paying your $60, remember, I'm saving $120 on the book, which is a good thing, I hope. You're able to get credit at other schools for taking an actual lab course, which I think is a good thing. So that's, how should I say, something that we had to grab onto in an emergency, and that's that. All right, let's get back to our lecture material. Don't forget, if you have any questions while you're taking the test, I will be checking my email frequently today, tonight, and tomorrow. Feel free always to ask questions, because remember, in my class, there's no such thing as a dumb question, even on tests. All right, we had talked about polyatomic ions and how you use them to show when you're forming a molecule. I did that yesterday. By the way, I'm being, Dr. White is being a good boy. And I've been keeping up with the videos on YouTube. And once again, I'm a YouTube star. And I'm up to date as of yesterday. and I'll get today's up later today. So anyways, yesterday, I had showed you how to determine how many atoms of different cation anions are in a molecule that has ionic bonds. Let's talk about covalent molecules and covalent bonds. And the covalent bond, chemical bond, on here, this is in your book, you don't have to know it's between similar or identical atoms, but you should know it involves electron sharing. And a lot of people say the basic unit is a molecule. I'm not going to get into that because I consider ionic also a molecule, but I'm an organic chemist. All right, switches on, full blast. You should know, what is a covalent chemical bond? It's a bond, chemical bond between two nuclei or two atoms, really it should say, that are shared electrons. A better way of saying that, a chemical bond between two atoms resulting from the sharing of paired electrons. And this one, you should know that a chemical bond is the sharing of pairs of electrons between two atoms. Again, I'll say it. You should know that a chemical bond is between two atoms resulting from the sharing of pairs of electrons. Remember, a pair is two. So how do we show this chemical bond, this covalent chemical bond? Well, let's look at hydrogen. When I talk about hydrogen, it really exists as H2, and that's hydrogen gas. Now, each hydrogen each hydrogen atom has one valence electron, and it also has one electron. And hold on while I do something. Hang in there. If I were in the classroom, you'd be seeing me, what I'm doing now, pulling up a periodic table, which I should have done earlier. Can everybody see the periodic table? Thank you, thumbs up, people. I love you. All right, now here's hydrogen. And when you're looking at covalent bonds, you consider the valence electrons. The valence electrons are the outermost electrons. We go to the top and we see, aha, one valence electron. I think that's the first time I said this semester, aha. Well, the second time now. But anyways, now hydrogen has one valence electron. Hydrogen gas is a molecule made up of two hydrogens. How do you show that? Each hydrogen has one electron valence, a dot. And therefore, if we have a bond between them, we show each one dot. They share electrons. And right here, this is a covalent bond. Now, only valence electrons are ever involved in a covalent bond. That's why I think they're the most important, because most of my work has dealt with covalent bonds. Let's show that again. One hydrogen has a single valence electron. The other one has a single valence electron. This hydrogen says to that one, I bet you know atoms could talk. They can't, not really, but hey, I've got an electron. Oh, that's a pitiful arrow. You've got an electron. Let's share. And they do. And this right here, a pair of electrons. Hold on, I see a question. Thank you. I always get tripped up on this. All right, can everybody see it now? Let me look at my thumbs up, people. Excellent. I keep on forgetting. One of these days I'll get it right. All right. Now, let's do this again. This hydrogen has one valence electron. This hydrogen has one valence electron. And this hydrogen says to this hydrogen, let's share electrons. And they do. And you form a chemical bond. Remember, a covalent chemical bond is a pair of electrons, 1, 2. And that's what it is. This is the covalent bond. And since they're sharing a pair of electrons, they're happy. Now, one of the things that I'll be teaching you is, other than hydrogen, all atoms want to have an octet, 8 valence electrons. The one exception is hydrogen. And notice this hydrogen, if we circle, that was an awful looking circle, has 2 valence electrons. And if we look at this hydrogen, it has 2 valence electrons. So the octet for hydrogen is 2, and they're both happy, which means they're stable. So when you're doing, everybody see the slide on there? Thank you. Now I remember. All right, now, when you do Lewis structures, there's 2 types of electrons you can see in a Lewis structure. One is called bonded electrons. And I'll never ask you the definition, but you should know this. If I ask you to circle the bonded electrons, you need to know what are bonded electrons. Those are pairs of valence electrons that are shared between atoms in a covalent bond. And generally we drop the word chemical. It's a covalent chemical bond, but we just call it a covalent bond. The 2 electrons the 2 electrons here between the hydrogen are called bonded electrons because they're involved in a chemical bond. Now, there's another type of electron, and those are the non-bonding electrons. And those are valence electrons, which are pairs of valence electrons that are not involved in the electron sharing, also known as the covalent bond. And we call those non-bonding electrons. And turns out sometimes non-bonding electrons play an important role in the shape of a molecule. And because of certain bonding electrons and non-bonding electrons, molecules have certain shapes. That's the reason why our DNA which I think you probably know more about than I, exists as a double helix because of bonding and non-bonding electrons and their interaction. But you didn't know chemistry is involved in your RNA and DNA, everything. So bonded electrons, pairs of electrons involved in a chemical bond, covalent bond. Non-bonding electrons are the pairs of valence electrons not involved in a chemical bond. And good news, it's practice time. I'll do a couple, then I'm going to let you have fun too. Dr. White shares. And so let's do, if I were to ask on a test 3 or 4 points, draw the Lewis structure for, and I'd give you this chlorine gas. I wouldn't ask you to memorize the name. So let's do this first. First of all, you have to find out how many valence electrons each atom in the molecule has. Chlorine, if we look over here, and hopefully you all see the periodic table, and I see heads bound going yes. Chlorine, halogen, it has 7 valence electrons. Remember, we're not talking about total electrons, 17. We're only talking about the valence electrons. Oh, wrong pen. Let's start all over. Chlorine, it has 7 valence electrons. Hopefully, and let me check with my thumbs up, people. Can you see the chlorine on the screen? Thank you, thumbs up, people. And let's do the Lewis structure of a chlorine atom. Remember, 1 dot on each side before you double up. 4, 5, 6, 7. Now, chlorine gas is Cl2. So I'm going to have another chlorine. 1, 2, 3, 4, 5, 6, 7. Now, notice right here, this chlorine has a single valence electron that's not in a pair, and this one has a single valence electron not in a pair. And this chlorine says to that chlorine, I've got an unpaired valence electron, you do, let's share. And they do. The non-bonding electrons, the other pairs of valence electrons, are still there. All right, let's take a look at this. And the question would be, circle the bonded electrons. And these are the bonded electrons. And notice there are a pair of them. Now, if I come over here, where are the non-bonding electrons? Those are pairs of valence electrons not being involved in a chemical bond. And there are a lot of them here. Now, if we were in class, you'd see me put my hand over the board, but I can't. But if we look at this chlorine, inside the box, how many valence electrons do you see? 2, 4, 6, 8. Am I not sharing again? Hold on. Let's see something. Oh, that ain't working. Okay, everybody's seeing it when all right, so that's 8 valence electrons, and that's called an octet. And if we do the same thing on the other one, I have this pair, and by the way, I just noticed I forgot something here. There should be a pair here. And therefore, on this chlorine, oh boy, that looks like a mess, but you can see 2, 4, 6, 8. And that also has an octet. And that's what, other than hydrogen, the octet is 2, but the octet rule is for all other elements, they share electrons in a covalent bonds to get an octet. All right, the next one on the list, if my memory serves me correct, is hydrochloric acid, HCl. Now, hydrogen has 1 valence electron. Chlorine, as you saw, has 7 valence electrons. So if I have my hydrogen here, and you were asked to draw the Lewis structure for HCl, this has 1 valence electron. Chlorine has 7. And now this electron says to this electron, hey, let's share. And they do. Now, the non-bonding electrons around the chlorine are still there. And this would be the answer you would put down. I'm showing you writing these out. You don't really have to do that on a test, but you understand how it is. Now, if we look here, here we have the bonded electrons. And I'll just shorthand for electrons that. And over here, we have the non-bonding. Electrons. And if we look at hydrogen, forget about the chlorine over here, just right here, you'll see you have 2 valence electrons, which is the octet for hydrogen. But if we look at the chlorine, including the shared valence electrons, we'll see in the circle I just drew 2, 4, 6, 8, and now chlorine has its octet, and it's happy. Let's see what's next on our practice time. Oh, it's a good one, water. Now, the first thing you have to do is find out the valence electrons for H2O, water. If we look at the periodic table, Hydrogen has 1 valence electron. Oxygen has 6. And let's go back. All right, now, this looks like the word hive, and no, I'm not going to talk about bees today. But anyways, I'm going to let you have some fun. Now, in water, the oxygen is between 2 hydrogens. And why don't you try drawing the Lewis structure for the molecule water, H2O? Go. I'll give you about 10 more seconds. I guess I also could do this. If you're done, give me a thumbs up. If you don't have video, do the hand clapping or the... All right, I think everybody's done. Let's do it. All right, now, hydrogen has 1 valence electron. Oxygen has 6. So I'll put 1 on each side. Then I'll double up. Now, organic chemists like to double up this way. You could do it other ways. And there's another hydrogen. Now, notice this hydrogen says to the oxygen, I've got a lone electron, valence electron. You do, let's share. And the same thing happens on this side. And they share. And it looks like this. Notice this hydrogen has 2 electrons, including the shared from oxygen, so it's happy, it has its octet. This hydrogen has 2 electrons, valence electrons, 1 from the hydrogen its own, they're sharing, and it's got its octet. Now, the oxygen, if we look at all the electrons, there's 2, 4, 6, 8. It has 8 valence electrons, so oxygen has its octet. Now, let's have some more fun. In your mind or on a piece of paper, the structure I just wrote, circle the bonding or bonded electrons in water. Circle the bonded electrons in water. I'll give you 5 more seconds. 4.5, 4 3/4. I got a slow clock. 5, time's up. What's a bonding electron? Electrons that are shared between atoms. So in water, this is one, this is the other. It's an awful looking circle. Looks more like a jelly bean, but anyways, got the job done. There are 2 covalent bonds in water. This is one, This is 2. So next time you're in a Zoom party with other people, because with our situation today, I don't think you're going to be at a regular party. But if you're at a Zoom party, which I do go to, they're fun too. They can get pretty wild, at least the ones I go to. But you can tell people in water, there are 2 covalent bonds. Did you know that? No, don't do that. People do not want to hear chemistry at a party. All right, I'm going to let you try one more because these are fun and they're good for your grade, which makes it even more fun. Draw the Lewis structure for ammonia. Now, the first thing you have to do is find out ammonia is NH3, 3 hydrogens, find the valence electrons for each atom. Hydrogen has 1 valence electron, nitrogen, N, has 5 valence electrons. Remember what I'm talking about will be on test 2, not test 1, that you should be taking later today. Well, I threw in that commercial. And go ahead. I will tell you this, the hydrogens, all of them are connected to the nitrogen. When you're done, give me a thumbs up or clap your hands with the little symbol on. If you're done early, please be patient. I try and give everybody enough time to finish. And if we were in the classroom, I would be doing this by looking around and seeing if people are still working on it. Let me just check something. My thumbs up, people. Can you see ammonia on the screen? Thank you, thumbs up, people. I love you. We're going to have a fan club meeting of the thumbs up people tonight at midnight. No, we're not. All right, let's do this. Nitrogen, 5 valence electrons, 1 on each side, you double up. Now, organic chemists like putting the lone non-bonding pair on top. And I'm an organic chemist, so I'll do that. Hydrogen, 1 valence electron. Now, if I do this, each of the hydrogens says, I've got a single valence electron. Nitrogen, you have a single, let's share. And they do. And the next hydrogen says the same thing. And the last hydrogen says the same thing. Now, I'll ask you 2 important questions. How many bond pairs or how many covalent bonds are in ammonia, NH3? I'll give you the answer. I see somebody already, a lot of you are getting into chat. I'm going to peek. Oh my goodness, let's do it. What is a bonded electron or covalent bond? Sharing pairs of electrons. This is one pair. This is two pair. This is three pair. So there's three covalent bonds. Another way of saying three pairs of bonding electrons. Now, next question is circle the non-bonding pair of electrons in ammonia. You try that. I could ask that on a test. In the molecule you just drew, I have on the screen, circle the non-bonding electrons. Time's up. If we look here, these two electrons are a pair of valence electrons. They're not being shared with any atom here. So these are your non-bonding. Your non-bonding electrons. And this is ammonia, NH3. Now, ammonia, time out for a little real life stuff about ammonia. NH3, ammonia is a very important chemical in our daily life. Our body uses ammonia in some extent, not that much, but in chemical industry and agriculture, ammonia is used a lot. Ammonia at room temperature is a gas. If you compress it, you can make it into liquid. It's also quite deadly if you inhale it. One of my more, how should I say this, not pleasant memories in the chemical industry was I was at this plant helping out. The plant manager asked me, could you supervise unloading a railroad car, hundreds of thousands of pounds of liquid ammonia? And I said, sure. It was deep summer, 9 degrees, humidity was almost as high, and you had to wear one of those hazmat suits. I had a full gas mask on, air tank in my back, and I supervised it. And halfway through, all of a sudden, I'm sweating, it's going into my eyes, burning. And I had to go like this, because if I went like this to wipe it out, I would be dead. Guess what? I didn't. I'm still alive. Now, ammonia, for many years, came from two sources, human and animal waste, mainly urine. And which made there wasn't that much on our planet. Back in 1910, two Germans, Haber and Bosch, came up with a way of making ammonia in chemical plants. We have a fancy name for that. It's called synthesized ammonia. Synthesize is a fancy word for to make. I'm a synthetic organic chemist. My training is making new molecules. But anyways, this was in 1910. And because Haber and Bosch came up with that, there was now a tremendous amount of ammonia available. Well, they had two ramifications. Ammonia can be used to make fertilizer. And that meant there was now inexpensive fertilizer available to our farmers, especially in the United States. And since there was a lot more food being grown, the population of the planet could expand, which it did. The other thing, ammonia can be used to make explosives and gunpowder, which now there was a lot of cheap ammonia. That meant companies could make a lot of cheap explosives for the military. And because of that, World War I lasted as long as it did, because there was cheap ammunition for the soldiers, which killed them, unfortunately, for the bombs. Same thing World War II and other wars. So when you look at chemistry and life, sometimes good things happen and bad things happen at the same time. This is a good thing. T. Nikki, you got nothing to apologize. Have a great day. I'll be posting this video later. Oh, time out for commercial from Dr. White. You should never, ever, ever, one more, ever have to apologize when you have to do something in life that's come up. Life happens. Trust me, I've been around the block enough times. Yeah, that's a good expression. Let's say I've been experiencing life long enough to know that's true. The other thing which some of you do that you never, ever, 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 ever have to do is apologize to me for asking a question, 2 questions, or many questions. Remember, in my class, there's no such thing as a dumb question. That means 1, 2, 3, 5. There's no limit. Well, yeah, there's a limit if I have to go to bed, but that's another story. All right, let's move on. You've had your Lewis structure practice time. I don't know why these came on here. Let's talk about single, double, and triple covalent bonds. Now, if there was this all molecules which each one had 1 pair of electrons being shared between atoms, there wouldn't be that many molecules in our daily life. And it turns out Mother Nature didn't stop there. Time out for a commercial from Dr. White. You know who's the greatest of all chemists and really the greatest of all organic chemists? Nope, not me. It's Mother Nature. Mother Nature is the greatest of all chemists and organic chemists. All you have to do is look outside your window or look at your screen, me, you, our skin, my clothes, the metal back there, all around us. Especially if you look at the flowers, trees, perfume, food you eat, that's all chemistry. That's all Mother Nature. Isn't she great? Yep. I'm a fan of her, have been for a long time. Now, when it comes to covalent bonds, you should know, I've just turned the dial up to 25 and it only goes up to 10, but I pushed it farther. There are 3 types of covalent bonds. The first covalent bond is called a single bond. A single bond, you should know, in which 2 atoms share 1 pair of electrons. Single bond. Double bond, you should know. A double bond is when 2 atoms share 2 pairs of electrons. Single bond, 1 pair of electrons being shared. Double bond, 2 pairs of electrons being shared. And the last type of chemical bond, covalent chemical bond, is the triple bond. Triple bond, in which 2 atoms share 3 pairs of electrons. Single bond, 1 pair of electrons being shared. Double bond, 2 pair. Triple bond, 3 pair. For those who know baseball, if you go to first base, what do we call that? A single. And it's like going 1, a single bond has 1 pair of electrons. If in baseball you go to second base, I like my expensive props I have. They are very expensive. Anyways, go to second base. What do we call that in baseball? A double. 2 pair of electrons, double bond. I wonder if somebody came up with those names watching baseball. Don't know. And finally, if you go to third base in baseball, third base, what do we call that? A triple. And when you have 3, yes, 1, 2, 3, I'm having fun. 3 pairs of electrons being shared, we call that a triple bond. Hang in there. There we go. Hi, everybody, all together. What's the first type of covalent bond? A single bond. How many pairs of electrons? One. What's the second type of covalent bond? Double bond. How many pairs of electrons being shared? Two. What's the third type? Triple. How many pairs? Three. So you have a single, double, and triple. I ran out of room for my three dots. So everybody together, just the names only. What's the first type of covalent bond? Everybody, single bond. What's the second type of double? I just gave it away. Second type of covalent bond. Everybody, yep, louder, double bond. And what's the third type of covalent bond? And the answer is triple bond. Remember, single bond, one pair of electrons, double bond, two pair, triple bond, three pair. And if we were in the classroom, I'd be telling the students, all right, come on, do it again. Let's fire up what are the names of the covalent bonds? First one, single bond. Second one, double bond. Third one, triple bond. And the whole class would be gung-ho and saying it, and everybody feels good. And unfortunately, I can't do it like that with you other than what I just did. Well, yeah, it was pretty fun. Now let's do some practice. Let's look at nitrogen gas. Nitrogen gas, which you're inhaling right now, has two nitrogens. And if we look at the periodic table, how many valence electrons does each nitrogen have? 5. And on a test, if I were to ask, draw the Lewis structure of nitrogen gas, 3 points each, how do you do that? Well, this has 5 valence electrons. Each nitrogen, I can draw the Lewis structure. Remember, dot on each side before you double up. Now, if we look here, each nitrogen has 3 single valence electrons. And this nitrogen says to this one, I've got 3 unpaired electrons. You have 3 paired unpaired electrons. Let's share them all together and form a covalent bond. And they do. And let's look at this. You still have the non-bonding electrons on top. First pair. Second pair. One from each. Third. And this is the valence structure, Lewis structure of nitrogen gas. Question is, what type of covalent bond is between the two nitrogens in nitrogen gas? Single bond, one pair, double bond, two pair, triple bond, three pair. Notice there's 1, 2, 3 pair. So that's a triple bond. And the next time you're with some friends, neighbors, or loved ones on Zoom or wherever, 6 feet apart, social distancing, remember, wear your mask. Oh, by the way, do not get near anybody who has a mask with the valve in it, because when they breathe out, any virus they might have comes right out too. I don't know why those masks aren't outlawed, but they aren't. But the next time you're at a Zoom meeting or a Zoom party or talking to friends via Skype and you see them breathing, hopefully they are, you can tell them, you know, you're inhaling nitrogen, and nitrogen has a triple bond because it has 3 pairs of shared electrons. Don't do that. People don't like hearing chemistry, but it's true. Now I'm going to let you try one. The other thing you're inhaling when you breathe is oxygen. And oxygen, each oxygen atom has 6 valence electrons. Why don't you try and draw the Lewis structure for oxygen gas, O2. All right, anybody need more time? Or I should say, give me a thumbs up if you're done. All right, I mean, I don't see everybody thumbs up yet, but I'll wait another 10.2 seconds. 10.1, time's up. Let's do it. All right, oxygen gas, and hopefully you all are seeing this. Each oxygen has 6 valence electrons. Remember, 1 on each side before you double up. Now, on a test, do you have to write the step? No, but I'm showing you how it works. Now, each oxygen has 2 unpaired valence electrons. And this oxygen says to this oxygen, hey, I have 2 single valence electrons. You have 2 single valence electrons. Let's share and we can form a bond. And now, if we look at this, oxygen, hold on. Oxygen has two non-bonding pairs of electrons there. Same thing here. Now, this pair says let's share, and they do. This pair, let's share, and they do. And now we have oxygen gas. And notice around each oxygen, I'll just look at one, how many valence electrons? 2, 6, plus 2 more, 8. So it's got its octet. Same thing here. Now, what kind of bond, covalent bond, is between the two in oxygen gas? And the answer is, which I think somebody already came up with, it's a double bond. And double bond has two pair of electrons being shared, which is what you see here. So the next time you're at a Zoom party and you see people breathing, or if you're talking to some friend on Skype and that friend hopefully is breathing, you can say, when you inhale, you know you're inhaling oxygen in the air, and that has a covalent double bond or double bond, which is two pairs of electrons being shared between the two oxygen atoms. Well, you don't have to. I don't think they want to hear it, but now you know that. So next time you breathe, inhale, you're taking in nitrogen gas, N2, with a triple bond, and oxygen gas, that's good, with a double bond. And that's keeping you alive, which is very good. Now, I'm going to do the next one. Hold on while I get a clean sheet. I'll do this one. Hydrogen cyanide, HCl, is a deadly gas, but hydrogen, 1 valence electron. Carbon, 4 valence electrons. And you can look at the periodic table. Nitrogen, 5 valence electrons. Now, it turns out carbon is in the center. Now, hydrogen looks at carbon and says, I've got a valence electron. You do a single, let's share. And they do. Now, that takes this out of the equation. Carbon still has 1, 2, 3 unpaired valence electrons. Notice nitrogen has 1, 2, 3 unpaired electrons. And the carbon says to the nitrogen, hey, let's share our valence electrons. And they do. 1 pair, this, and say this, another pair, this, and third pair, this and this. And you get this, and I'm about to sneeze. Excuse me. And yes, I covered my mouth and with my elbow, not my hand. And then the non-bonding electrons here on nitrogen are still there. And notice now, hydrogen cyanide has a single bond and a triple bond. And I'm out of time. Oh my God, time flies when you're having fun with covalent bonds. Does for me, hopefully for you. All right. Don't forget today, just log into Labster today or tomorrow or sometime before Tuesday and try the lab that's listed in the syllabus. Also, between now and tomorrow, 9 a.m., you should download test number 1. I sent out the email with the password, and take the test. Remember, don't cheat. And I've talked about what you shouldn't be doing. Take as much time as you need, but realistically, you should all be able to knock it out and finish it in about 35, 40 minutes. Don't forget, use proper significant figures for all calculated answers. It's written under your name, but I'm telling you now. And with that, have a nice rest of the weekend. I'm out of here. Gang gazoon. Be healthy. Good luck on the test. By Sunday or sooner, I'll have the test scores in Blackboard. With that, bye. And if you have any questions, I'll stick around for a couple minutes.